with you. Okay, so this is the lesson that if you look up on YouTube, you'll see this exact lesson. All right, so the first thing we're going to do is review some old properties that we know. We already know about the associative and commutative properties of addition and multiplication. These you learned. You guys remember this? It was in 3rd grade. Y'all remember first being introduced to the associative and commutative properties? Probably not. But then you got to see them again in middle school. Do you remember them from middle school?
Yes.
Okay, so associative says we can regroup with addition and it doesn't change the outcome. Commutative says 2 plus 3 is the same as 3 plus 2. So associative says we can regroup. Commutative says we can switch order. And that works for addition, and it also works for multiplication. Does it work for subtraction? Is 2 minus 3 the same as 3 minus 2? No. Does it work for division? Is 2 divided by 3 the same as 3 divided by 2? No. But it does work for addition and multiplication. And then this one was just common sense. The additive identity property. But we do use this to be able to solve equations. A plus 0 is the same as 0 plus A, which is A. So if we add 0 to anything, does it change?
No.
No. And the existence of an additive inverse. For every A, there exists the opposite of A, so that when I add them together, what do I get?
0.
0. Okay? And then the associative and commutative properties of multiplication work just like addition. The multiplicative identity, what's the number that you can multiply by that it doesn't change anything? 1. So A times 1 is the same as 1 times A, which is A. And the existence of a multiplicative inverse. For every non-zero number, there exists a 1 over that number. Isn't that the same as the reciprocal?
Yes.
A reciprocal, so that when I multiply reciprocals, what do I always get?
1.
1. And then the last point here is the distributive property. Okay? And the distributive property of multiplication states that if I have a number times a grouping, a binomial, I can distribute this through. And we get A times the first term plus A times the second term. Okay? So all that was review what you've seen, all of that. And then the properties of equality. Now, this is what you used when you first learned how to solve equations. We just didn't state what every step was. Now, the ones that we're going to focus on are these starred ones. The addition property of equality says that if I have a balanced equation and I add some constant to one side, if I add the exact same amount to the other, it remains balanced. Or if the subtraction property of equality says if I subtract the exact same things from both sides of an equation, it remains balanced. Or if I multiply both sides of an equation, the multiplication property of equality, it remains balanced. Or if I divide both sides of an equation by the exact same thing, it remains balanced. Now the reflexive, symmetric, transitive properties, we're going to use these more when we get to the geometry part of this class. And then the substitution property of equality we will talk about soon. We'll use that when we're doing systems. Okay, so Joshua was trying to finish his homework in instructional focus. That's what we used to have last year to help us with our homework before class begins. Though he is a strong math student, he was rushing through his problems to try to get credit for just completing the assignment. That was not smart of Josh, was it? No. All right, explain each step of his work and describe where he goes wrong. What should he do to correct the problem? The first thing we're going to do is to identify the justification for each one of the steps. And then once we do that, we're going to go back and point out Joshua's errors. Okay, so it looks like between here and here, what did he try to do? What do we call that? Distribute. So what did Josh use? He used the distributive property. Okay, you can add that to your notes. All right, between the second and third step, what happened between the second and third step? What did he do? How would you describe what he did between these two steps?
He combined the x's.
Combine like terms. He combined the x's. He combined like terms. Okay, to go from here to the next line, which is here, what did he do? What property did he use? He sure did. He used the subtraction property of equality. He subtracted equal amounts to both sides. Therefore, the equation remained balanced. The subtraction property of equality. And I'm just going to put an equal sign. Okay, to go from here to the next step, what did he use? The addition. Good. The addition property of equality. And finally, between this step and the final answer, what did Joshua use?
Division.
The division property of equality. Okay, so he had the right idea, but Joshua made two mistakes, didn't he? Joshua made two errors, not just one. Got to be a little more thoughtful when you're working on your homework. Okay? So, Lou, what do you see the first error is?
In the addition property of the addition property of the equation, he put the add 8 in the wrong place.
You just want him to line it up better?
Yeah.
Okay. He definitely could have done that. But that's not one that I would have been picky about. I'm picky about other things. TJ?
Yes. Okay, the 12 should be positive.
The 12 should be positive. Joshua did not distribute correctly, did he? Joshua dropped the negative when he was distributing. He forgot about the negative. He just took the 2 over there, didn't he? You can't just do that. You got to multiply the negative 2 times the 6. So Joshua should have made this a positive 12. Should be a positive 12. Okay, Sabrina, did you see another one?
That was the last.
You saw that one.
Oh,
Okay.
why did it change from on one side from x plus 8 to x minus
You found it. It's right here. So, Rose, is that what you saw too?
8? Yeah.
Yeah. Okay, so somehow in this combining like terms step, somehow when combining like terms, he just changed the sign. The positive 8 should remain positive. Okay. All right, I would like you to try this problem. I want you to solve the problem and then out by yourselves justify, give your mathematical justification or your reason for validity for each of your steps. Go.
What do you mean by reason?
Which property? Okay, when you're done, take a look up. Now, if you chose to move the negative 3x first, and yours doesn't exactly look like mine, does that mean you're wrong?
No.
No. You just need to make sure that your justification matches your step. So this is what I chose to do. All of us had to distribute first. But then we had choices. After we distributed and then we combined like terms. Then we had choices of what we wanted to move. And so as long as your step matches, as long as your justification matches your step, you're good. Okay, I have a little reminder over here. Our reminder says, if we're solving a linear equation and we get to the end and our x cancels out, like we have 5x minus 5x and it goes away. There's two possibilities. One of them is we're left with something that's true, like 4 equals 4, or 0 equals 0, or negative 8 equals negative 8. We're left with a true statement. And if that happens, then our answer is all real numbers. Because any real number that we plug into that equation will work. But if we get something that's not true, like 2 equals 7, 0 equals negative 5, if we get anything that's not true, then there is no solution. Because nothing I plug into that equation will work. Okay? Now, usually we just get one answer. Usually the variables don't cancel. But if they do, these are the two situations that could occur. So be looking out for that when we start working on some problems. Okay.
I
Yes.
got x equals negative 6.
You got x equals negative 6. Okay, let me come take a look at your work. And while I'm doing that, just go ahead and solve the next equation. You don't have to give me the steps for it, even though it says to. Go ahead and solve the next one.
3. You're just going to write the x beside it. That's what the sheet. Okay. And then, or if you subtract with the 2x, it has to line up there. You just drop it. Okay.
Right here, what y'all guys move? The 8, the x, the negative 3x, or the negative 3?
Wait, what? Oh, okay, I did something wrong.
I'm going to move this negative 3x. So I get 8 plus 2x equals negative 3. And then I'll subtract 8. So I get 2x equals negative 11. So we all should have gotten x equals negative 11 halves, which is the same as negative 5.5. If you wrote it like that, that's fine. Okay, how'd you do? All right, so what we did was the distributive property. We combined like terms. I chose the addition property of equality, followed by the subtraction property of equality, followed by the division property of equality. All right, the last thing we're going to look at is some equations that are a little more interesting, and I really like these. Okay? So, what we have here, we're going to start off with some equations that look like they are almost fraction-like. They have denominators. And I know you've solved these before by getting a common denominator. But what I want us to do, and I want all of us to do this, is to solve these by clearing the denominator. Get rid of the denominator completely. And the way you clear a denominator is to multiply each term through by the common denominator. So let's look at problem number 1. Problem number 1 is x divided by 2 plus 2x divided by 3 equals 5. What is a common denominator for 2 and 3? 6. Okay? So we're going to take each term, and multiply it by 6. Every single term.
Wait, don't
So,
make it just
what is 6x divided by 2? 3x. What is 12x? 12x divided by 3? 4x. And what is 5 times 6? 30. Does that look a lot easier than that?
7x equals 30.
Yeah, so 7x equals 30. So x equals 37ths. Now, when you're left with an answer that's an improper fraction, as long as it's simplified, and it's not really a word problem we're dealing with where we'd have to decide if we need to round up or round down or anything like that, just leave it as a simplified improper fraction. 37ths. That is exact. Yes, sir.
Oh, how did you get 6?
Yeah, I'm not getting that.
Okay. How do you find a common denominator?
Fun.
You look at your denominators and go, what's the smallest number that both of those divide into?
Oh, 4. Would it work with like one of their bigger denominators? Like
Oh yeah. Let's look at number 2. On number 2, we have denominators. We've got 6, 8, and 12.
24.
So 24 is the smallest number that all 3 of these divide into. Does everybody see that? 24. So we're going to multiply this by 24, and this by 24, and this by 24. But do you see if I did straight multiplication, it's going to get really big?
Yeah.
So watch this. This is 24, but it's being divided by 6. How many times does 6 go into 24?
3.
4 times.
4 times. Okay, this little group right here is not paying attention to me. So if you guys already know what you're doing, that is fine. And you are welcome to work ahead, but you may not talk and interrupt others from learning. Thank you. All right, how many times does 8 go into 24? 3. So this has to be multiplied times 3. And how many times does 12 go into 24? 2. So this gets multiplied times 2. So we get 4 times the 5x minus the 3 times the 3 minus x equals 2 times 4x plus 3. Okay, take it in. See if you follow what just happened. Okay, I'm going to show you one more time now that you know where we're going. I'm going to show you how to get there. Okay, my 3 denominators are 6, 8, and 12. The smallest number that all of these divide into is 24. So each one of these terms has to be multiplied times 24. But if I distributed the 24 through all of this, the numbers would get really big. So since the 24 is really divided by the 6, I can say 6 goes into 24 4 times. And 8 goes into 24 3 times. And 12 goes into 24 2 times. So it ends up being 4 times the 5x minus 3 times the 3 minus x equals the 2 times the 4x plus 3. And so this gives us 20x minus 9 plus 3x equals 8x plus 6. So 23x minus 9 equals 8x plus 6. And we subtract 8x, or, at this point you pick. And so we get 15x minus 9 equals 6. Add 9 to both sides. So we get 15x equals 15. Divide both sides by 15 and x equals 1. All of that for 1.
Oh, I did.
Okay, we're going to skip number 3 because there's really not anything special about number 3 except it has some decimals in there. Whoop whoop. Oh well. We're going to go to number 4 because number 4 reminds us of one other little rule. It is not an equality. Number 4 is an inequality. And what's our extra little thing we have to pay attention to if we're solving an inequality?
Multiplying by negative.
That's right. So if you multiply or divide by a negative, what happens?
The inequality switches.
You switch the inequality. Okay, so no big deal, no fractions in this or anything. It's just the only new part was the inequality. So we're going to distribute that negative 2. We're going to combine like terms. And here you get to pick. What would you like to move? So if I chose to move the x, and then I would have to move the 15, and then I would have to divide by a negative. So when I'm dividing by the negative, that's when it changes the inequality. So we get x is less than, and 28/3 is going to be my answer because it doesn't simplify. If you wrote 7 1/3, I would certainly give you credit for that. No, I wouldn't. It'd have to be 9 1/3 to get it right. 7 1/3 to be wrong. Okay, the back side of this worksheet is your homework. Okay, so I'm going to stop recording now. You've got about 5 minutes of class time remaining, so use that to get started. If you're struggling with those fraction problems, start with those.